Hello, my name is Sepaher Ghassemi, and today we will be doing a stoichiometry problem. Today's problem is lead-2 sulfide burns in the presence of oxygen to produce lead-2 oxide and sulfur dioxide. If 143.5 grams of lead-2 sulfide burn completely, how many grams of oxygen must have been present? So what we're going to start with today is our skeleton equation. Our skeleton equation is basically our base. It's going to show us our reactants and our products. Our reactants are lead-2 sulfide, lead having a charge of +2, sulfur a charge of -2. Since those charges cancel out, don't have to write the subscript. Oxygen, lead-2 oxide, since lead has a charge of +2, -2 with oxygen, those cancel out, and then we have our sulfur dioxide. Since these are being heated to turn into these, we must draw a triangle above the arrow to show the heat and burning. So what we want to do next is just balance the equation so we can have the same amount of elements on the left side, on the right side. So we will write our three elements, which are lead, sulfur, and oxygen. So we can see that we have one lead on the left, one lead on the right, one sulfur on the left, one sulfur on the right, 2 oxygen on the left, and 3 oxygen on the right. Our goal is to have the same number on left and right side of every element, and we see that is true for the lead and the sulfur, but not for the oxygen. So we have a 2 and a 3, so what we want to do is find the least common multiple, which is 6. So we want 6 oxygen on the left and 6 oxygen on the right. To get 6 oxygen on the left, we can write a 3 right here. And that 3, you can think of it as distributing. So the 3 times the 2 would give us 6 oxygen. And now we want 6 oxygen on the right side. So to do that, we would multiply this and this by 2. So the 2 times the 1 oxygen would give us 2 oxygen, and the 2 times the 2 would give us 4, so 2 plus 4 is 6. But when placing the 2 here and the 2 here, that also gives us 2 lead and then 2 sulfur. So we have 2 lead and 2 sulfur on the right side, but only 1 lead and 1 sulfur on the left side. So we want to multiply the lead-2 sulfide to get 2 sulfur and 2 lead. So now we have our everything is on the same one. This is the left and the right, and this is our balanced equation. Oh, we need to add a 2 right here. This is our balanced equation, and we can use this equation for whenever we need a molar ratio. A mole is 6.02 times 10 to the 23 atoms of any certain element, compound, or substance. So we can know that how many moles of this is equal to this, or the other way around. So what we want to do next is get to the second part of the problem, which is if 143.5 grams of lead-2 sulfide burn completely, how many grams of oxygen must have been present? So we want to find the molar masses of the 2 parts of our next step. And those 2 parts are the lead-2 sulfide and our oxygen. So molar mass is basically how much 1 mole of a substance, element, compound, anything weighs. So we can break the lead-2 sulfide down into lead and sulfur. So we know that by looking at our periodic table, the mass of lead is 207.2 grams, and the mass of sulfur is 32.06 grams. So if we added these, we would get 239.26 grams, but since if we use our sig figs, we see that the lowest place used, like next to the decimal, is the tenths place. So we must round, so the 239.26 grams would round to 239.3 grams, being the molar mass for lead-2 sulfide. And now for the next step is our oxygen and our O2. So 1 oxygen is 16. So if you want 2 oxygens, you can either multiply 16 by 2 or add another 16, giving us 32 grams. So what we want to do is go from, as the problem said, grams of lead 2 sulfide to grams of oxygen. So what it gave us is 143.5 grams of lead 2 sulfide. So the unit we have here is grams of lead 2 sulfide, and what we want to do is cancel that out. So we will write it right here. And what we want to go to from grams of lead 2 sulfide is to a mole of lead 2 sulfide. So we can look at our molar masses, and we know that 1 mole of lead 2 sulfide weighs 239.3 grams. Now that we have our grams of lead 2 sulfide filled, we can cancel them out. Now we have a mole of lead 2 sulfide. So we want to cancel that out and write that there. And we want to convert that into moles of oxygen. And by looking at our balanced equation, we would know from our molar ratios that for every 2 moles of lead 2 sulfide, there's 3 moles of O2. So we would write the 2 next to the lead 2 sulfide and 3 next to the oxygen. Now that we have 2 moles of, we have a mole of lead 2 sulfide there and a mole of lead 2 sulfide there, we could cancel. And now we want to cancel out our mole of oxygen. So we want to go from mole of oxygen to our last, what we want our answer to be in, which is grams of oxygen. So we know that 1 mole of O2 weighs 32 grams. So what we started with, and now we can cross out the moles of O2. So what we started with was 143.5 grams of lead 2 sulfide, and now we're ending with 32 grams of O2. So what we want to do is when we put it in the calculator, we're going to want to multiply the top, put that on top, and then multiply the bottom together and put that on the bottom and divide it from the top. So what we would do is we would have 143.5 times 1 times 3 times 32 over 239.3 times 2 times 1. And then on the top, we would get 13,776. And then on the bottom, we would get 478.6. And then the answer of this problem would be 28.783. And now we're not done yet though. So we go back to our given and we see that there we have 1, 2, 3, 4 sig figs. So we're going to want our answer to have 4 sig figs as well. So we have 5 numbers. So we want to go to the 4th number. So 1, 2, 3, 4. And we want to round to that number. So since the 3 is not large enough to round that up, we would stay at 28.78. And since our last unit that we ended in was grams of O2, that's going to be our final unit too. So our final answer is 28.78 grams of O2.